Hello and welcome to this new tutorial. This one is very special and very important because we're going to do two essential tasks of NLP, which are tokenization and filtering the non-frequent words. We're going to do that at the same time by creating two dictionaries, one that is going to map each word of all the questions to a unique integer, and one other dictionary that is going to map all the words of all the answers to a unique integer. And while creating this dictionary, we will add an if condition that will check if the number of occurrences of the word we'll be dealing with in the loop will be higher than a certain threshold that we will choose in this same tutorial. And if that's the case, we will include that word in this dictionary. This word will be one of the key identifiers of the dictionary. And on the other hand, if the number of occurrences of the word is below the threshold, well, we will not include this word in the dictionary. So that at the same time we proceed to the process of tokenization by getting separately all the different words of all the questions and all the answers and attributing a unique integer to each of these words, and at the same time we filter out the words that don't appear frequently in the dictionary, that is, that are below the threshold that we're going to choose. And speaking of the threshold, this is the first thing we will do in this tutorial. We will choose a number for that threshold, and for the words having a number of occurrences below this threshold, we will exclude them. So let's do it. Let's start by choosing this threshold. So we're going to call it naturally threshold. And in general, when doing this kind of task in NLP, I recommend to filter out the 5% that appear the least in the whole corpus of words. And considering the total number of words in our corpus of words, well, a good threshold for our situation would be between 10 and 20. Remember, you can experiment with different hyperparameters, different values for the hyperparameters. The threshold is one of them. So I'm going to choose 20 here. That will give us a removal of 5% of the least appearing words, but feel free to either increase the threshold, that will reduce the training time, or if you have a powerful computer, you can also try with a lower threshold, but not too low because then it will be too overwhelming for the model to learn. So here we're going to choose 20, and there we go. Let's create now our two dictionaries. One dictionary that will map each of the questions words to a unique integer, and one other dictionary that will map each of the answers words to a unique integer. So let's start with the dictionary for the questions words. And in the spirit of making all our variable names clear, we're going to call that dictionary questions words to int, because we're mapping all the questions words to a unique integer. So questions words to int, and as usual we initialize it with some brackets like that. Alright, then we are used to directly getting to a for loop, but first we need to initialize a variable to 0, which will be the number of occurrences of the word we will be dealing with in the loop, because we're going to loop over the words in the word to count dictionary that we created before. You're going to see, but we need to introduce a new variable right now that we're going to call word number, and we will initialize it to 0 because basically we're counting from 0. And now we can start the for loop. So for, and as we say, we loop over the words of our previous dictionary, so loop variable word, and also count, because for each of these words we're going to get the number of occurrences of these words, which we will get thanks to our word to count dictionary that we created before. So word count in, well, we can get the words and the count of the words in that same entity, the word to count dictionary. So that's in word to count, and to get them we need to add here dot and items with parentheses, and this will get us the words, which are the key identifiers, and the number of occurrences, which are the values of the key identifiers in the word to count dictionary. So colon, and then let's start the for loop. So as I said at the beginning of this tutorial, now we have to make an if condition to make sure we include only the words that appear a number of times higher than the chosen threshold, which is equal to 20. So what I'm going to add here is an if condition that will check if the count, which is the value of the dictionary associated to the key identifier word, the word we're dealing with right now, the loop. So if count, that is the number of occurrences of this word, is larger than the threshold, well, what are we going to do? We can even include the threshold if we want to keep the words that appear at least 20. That's not a big deal. That won't change much, but we can include it. And if that's the case, what do? Well, we will include that word in the dictionary that we're creating right now and that we're calling questions word to int. And therefore, right now I'm taking this dictionary, I'm copying that, I'm pasting that here. And so you know the trick. I'm going to create the key and the value at the same time. And the key, which appears in the square bracket, is the word we're dealing with right now and that we choose to include in this dictionary because its number of occurrences is larger than the threshold of 20. So questions word to int word. We just created the key and now we must associate it to it the value, and the value, as we said, is a unique integer, right? Because our dictionary maps the questions word to a unique integer. And that's what this word number will be useful for us right now. It's because we're going to simply create these unique integers by starting from 0. So the first word that we find appearing more than the threshold will be associated to 0. Then the next one that we find appearing more than the threshold will be associated to 1. Then the next one to 2. Then the next one to 3. Well, you get the idea. We will increment the word number each time we find a word appearing more than the threshold. And therefore, the value associated to this key identifier word in our questions words to int dictionary is the word number variable. For the first word, it's 0, but then we will increment it right now so that the next word we find appearing more than the threshold will get the incremented value of the word number variable. So right now what we gotta do is increment word number, and that's why I'm adding here plus equals 1, which is exactly the same as word number equals word number plus 1. Therefore, the next frequent word will have the key identifier 1, then the next one after that will have the key identifier 2, etc. Alright, and that's it. That creates our questions word to int dictionary. So we get this dictionary that encodes each of the words of the questions by at the same time only including the frequent ones, or at least the 95% most frequent one. And now we're going to do the same for the answers. We're going to create a new dictionary that we're going to call answers words to int, and that will do the same. It will not only include the 95% most frequent words of the answers, and at the same time associate them to a unique integer. And so you get that this is exactly the same logic. We just need to copy this, and I'm going to paste that just below. There we go. And like before, we just need to replace question by answer and we will be good to go. So questions word, I'm going to replace that by answer. Answers words to int, perfect. Word number, we can keep that because it was only used for the previous for loop, and therefore we can reinitialize it to 0 because that's it. By this code section here, we get our dictionary, so we can just use it again, that's fine. So word number is fine. Then for word count in word to count items, all good. If count is larger than the threshold, well, our answers words to int dictionary will create the word key that was accepted because it appears more than the threshold, and the value word number, which is its unique integer, identifying and encoding it. And here eventually that's the same. We just need to increment the word number so that the next word that we find appearing more than the threshold gets a new unique integer to be encoded with. There we go. Our two dictionaries are created. We not only removed the 5% least frequent words, and at the same time we encoded all the words of our questions and of our answers. So that's a good thing done. So now we're going to execute this section to have a look at our two dictionaries that we just created. There we go. We have them. All good. So let's have a look. First, let's have a look at the first one corresponding to the questions, which is right here. Questions words to int. And there we go, we get all the words of the questions, and for each of them a unique value identifier, which is of course an integer. All right, so you get all the words here, and that will be very useful for our future sec-to-sec model. And in general way, that's the common task to do in natural language processing. Of course, you understand that right now we are only doing natural language processing. We have not attacked deep NLP yet. The deep part will come when we get to the deep neural networks. That is when we get to the sec-to-sec model. This, what we're doing right now, is just the common process in NLP, but that's, of course, very important. And let's have a quick look now at the answers words to in dictionary. So that's the same. You have all the words and a unique integer for each of these words. All right, perfect. So let's close this. And now let's move on to the next step, which will be quite simple. Actually, it will be to add the final unique tokens to our two dictionaries that we just created. And that's basically the end of strings, start of string, SOS. Well, the last unique tokens that we need to add to our dictionaries, which are essential tokens to consider when building the sec-to-sec network. So we'll do that in the next tutorial, and until then, enjoy Deep NLP.